Hello everyone, and welcome to our Seamless Authentication with Typing Biometrics webinar, a collaboration between Microsoft and TypingDNA. Our speakers today are Jas Suri, Program Manager, and Nasos Kladakis, Principal Program Manager at Microsoft, and Tudor Goicea, Chief Revenue Officer, and myself, Madalina Burci, Chief Developer Growth at TypingDNA. In the next hour, we'll go through some short introduction to Azure AD B2C and TypingDNA, followed by a live demo of their integration and a glimpse in the future of authentication. We'll have time at the end for questions, so we encourage you to ask us via the Q&A chat, and we'll also send you a short feedback survey afterwards. Without further ado, let's welcome our first speaker, Nasos.
Thank you, Madalina. Thank you, everyone, for your time today. I want to welcome you from my side. I would like to start my presentation by sharing a few thoughts about customer identity and access management. It is obvious to all of us that work in this space for years now, and after talking to thousands of customers, that when customers and companies, when organizations are interacting with their customers, with their citizens, with their consumers, the end user is the king, right? Everyone wants to pay attention to what the end user really wants. And as a result of that, we make customization and the ability, the frictionless experience of the end user, the number one thing that an e-commerce site, a loyalty site, a civilian government site needs to achieve from their customers. So eliminate friction from the customers, fully customizable experience are the number one thing, the two things that someone really needs when they have a customer identity and access management side. At the same time, though, security is really important. So we try to have a seamless experience with security as much as possible integrated in this process. And at the same time, we need to have a system, a reliable system that will grow as the businesses grow and be able to handle global large scale. So we really believe that all these things can be achieved by Microsoft's customer or citizen or consumer, if you want, identity and access management solution, Azure Active Directory B2C. In the next slide, we're going to see exactly what Azure Active Directory B2C is. So Azure Active Directory B2C is an identity and access management platform for your external facing application, for your citizens, for your consumers, for your customers, for your end customers. And the way it operates is that Azure Active Directory B2C is the platform in the middle where you can integrate all your applications, your APIs, web or mobile applications and APIs that you want to expose to the world, to your external users. And by doing that, Azure Active Directory B2C is in the middle, protecting these applications, making sure that the authentication to these applications will be secure and seamless, and it exposes these applications to the world with any third-party identity provider you like. So you can allow your consumers, your customers, your citizens to access your applications with social providers from Facebook and Google to WeChat and Twitter, but also by using corporate credentials or government and business credentials that your customers really like to use. Any IDP protecting any of your applications that you want to expose to the world. This publishing of applications obviously is happening in a completely white label environment and completely customizable environment. So the journey of the user when they access your applications could be completely flexible and customized to the needs of these customers. And at the same time, on the back end, your applications trust Azure Active Directory B2C for all the authentication parts, the sign in, the sign up, the profile editing functions. And Azure AD B2C offers to you all kinds of analytics, all kinds of insights on how the users are using the service. And you have the flexibility to integrate your applications and Azure Active Directory B2C with any other external system that holds information that either you need to read or write during the interaction with the customers. But all these are pretty much, common sense on when it comes to a customer identity and access management solution. So what is the real power? What's the real differentiation behind Azure Active Directory B2C? Let's see in the next slide, the real engine, the power behind all this. So the engine of Azure Active Directory B2C that offers all the flexibility, all the security, all the reliability, and the main benefit of Azure Active Directory B2C is Identity Experience Framework. This engine that you could see like an orchestrator is the core of our solution. And I want you to follow me in the journey of the user as I will describe what we see in this slide. So imagine that you have an application, a web application, mobile application, an API that in this slide is described as relying party. So relying party is your application, the application you want to expose to your end users. And your end users are coming to this application, to that URL, to that mobile application from anywhere, from all kinds of mobile devices, of laptops, of desktops, of any kind of ways that they can interact with you. And when a user comes to your application and wants to initiate an identity-related process, like if that user wants to authenticate, if that user wants to sign up and create a new profile for your business, or this user wants to sign in and edit their profile, then this application says, okay, I sense that something that has to do with identities is happening. So I will now seamlessly send the user to the party I really trust for this kind of interaction. And the party that your application trusts is Azure Active Directory B2C in this case. So your application has a really secure integration with B2C. And when an identity-related process is happening, it redirects the user to Azure Active Directory B2C to securely handle this kind of process and experience. Now, Azure Active Directory B2C, when it takes on, it understands, it identifies the kind of the user, the devices that are coming in, the different factors from the IP to the day to different factors of this interaction, and calls the right policy. These policies are the user journeys, are the steps that describe the user journey of the end user. And this journey is what the user should see, how many options for authentication these users will have. Should I send him, an option of using social providers? Should I allow them to use username and passwords? Or a second factor is required, an email validation, collect additional information, interact with external systems. Identity Experience Framework actually uses this policy to exchange information between all these various systems you see on your screen. And at the end of the day, when the user journey is successful, the only thing that the application wants is a token that goes back to the application and says, I did everything I had to do with this user. I can verify that this user is valid. Please allow that person to start working in your application. So this flexibility that Identity Experience Framework offers is the real power of Azure Active Directory B2C, because it allows you to have flexible, fully customizable, and completely secure journeys between the user and your application. This flexibility actually allows us to have integrations like the one that we're going to discuss today with TypingDNA and other add-ons, either custom or that you can find in the market, and add all kinds of experiences, security experiences, CRM experiences, identity verification experiences to the journey of the user. Azure Active Directory B2C offers many capabilities natively, but it's a great thing that can get additional support. You can get additional benefits by integrating third-party solutions, non-Microsoft solutions, like the ones we're going to discuss today. This, again, is a really a big differentiation for Azure Active Directory B2C, as your application doesn't have to have too many identity components inside the code of the application. So you don't have, every time you want to make a change, to go in the code of your application and make changes in many different places to make sure that the identity processes will go well. You just rely and export and outsource, if you want, all the identity experiences to Azure Active Directory B2C and the Identity Experience Framework engine. This solution is used by thousands and thousands of customers all over the world because of the security it offers, the flexibility that allows integrations with all kinds of solutions, and the scale that it can offer in a global market. As you can see in the next slide, one story we would like to share with you among the thousands of stories we have with Azure Active Directory B2C is with Subway, a customer that we hope you recognize. It's one of the customers in the food industry, a retail customer, where people can log into their mobile and web applications to order food in United States and Australia. And Subway has millions and millions of users every day, actually, millions and millions of transactions every day. And the main reason they chose Azure Active Directory B2C is because they made sure it can handle their scale. And in this environment we're living in of all the pandemic and the issues we deal, and people rely on e-commerce experiences more and more, they could use Subway in a reliable way, no matter how many millions of users were logging in every day to their websites and mobile applications. And with that, I would like to thank you and pass the baton to the next presenter. Thank you.
Thank you, Nasos, for this introduction. And next, we're going to talk about TypingDNA, a company that recognizes people by the way they type. Today, there are 3 ways in which you can authenticate a person. Through what they know, like their password or their PINs, through what they have, like a phone number or an email address, or through what they are. The latter is called biometric authentication, and it can be further split into physiological, like your face or your fingerprint, and behavioral, like the way you talk, you walk, or you type. TypingDNA activates in the field of behavioral biometrics, more specifically in keystroke dynamics, also known as typing biometrics. And these type of authenticators are more robust than the physiological ones because the samples used in the process are different every time. No 2 typing patterns are identical, not even for the same person, which makes this very hard to imitate by the attackers and therefore making it less vulnerable. And to achieve this level of accuracy, our proprietary deep learning algorithms take into account a multitude of factors, such as the time you spend pressing each key, or the time between keys, the mouse movements from your desktop applications, as well as the way that you hold your mobile device, and the number of fingers that you use for typing. This makes our solution very secure, compliant, and user-friendly, while working in the background for both mobile and desktop applications. There are many risks associated to identity fraud and account takeover. Besides the financial losses, a company also risks their reputation and the customer churn. That's why you want to make sure that your clients and your employees are very protected. And in order to achieve this, passwords alone are not enough because they are guessable, they're very easy to hack, they're often shared or reused, and they're very vulnerable to attacks. And in fact, 80% of the data breaches happen because of poor passwords. And adding more complexity to them doesn't help so much. It just gives the users a false sense of security. The secret here is adding an extra factor authenticator, a second one. And we see this being a compliance requirement. For example, in Europe, the banking authority enforces this strong customer authentication by adding a second factor in the shape of knowledge, possession, or inherence. The good news is that the keystroke dynamics are already approved as an inherence factor, so you can safely use the TypingDNA in your solution in order to meet compliance requirements. And let's not forget about user experience, which is more important than ever. Today, this can give you the competitive advantage and it can bring you customers or stop your clients from switching to another product or service. And just think how Revolut just disrupted the banking industry by providing a superior experience in their app. You can do the same with your users by using TypingDNA because we don't interrupt and don't interfere with the user journey in your platform. We don't require any device switching or installing additional software, and it works seamlessly on both mobile and desktop applications. Your users just need the regular keyboards. We also see a change in attitude towards biometric authentication, with the majority of users nowadays using this already or planning to do so in the near future. And with this increase in usage also comes an increase in concerns for privacy. Some of the biometrics could be considered as intrusive. And here we've seen lately a lot of debates around facial recognition, which is considered by some people being invasive and biased. And companies such as IBM already announced dropping out of it. And here, in this growing market, typing biometrics are a very good, user-friendly, and secure alternative. And if we made you curious and you want to give it a try, let's see how this works in an Azure AD B2C implementation. I want to remind you that you can still ask us questions during the presentation on the Q&A chat, and I'm passing the floor to Jas, who is going to take us through a live demo.
Thank you, Madalina. So I'm now going to go through the actual integration and what the user experience is and how this all works. How do we connect TypingDNA and Azure AD B2C together? So essentially, looking at this diagram, the user starts by going to a specific website, wherever you're hosting your services. It could be your e-commerce website. And your e-commerce website will be protected with Azure Active Directory B2C authentication. When the user tries to log in at your website, the user will be redirected to the Azure Active Directory B2C credential entry form, where the user enters their email and password. Now here is where TypingDNA comes in and starts to profile the user's typing characteristics to try to learn and understand how this user types, and use this as a second factor during their subsequent sign-ins. So how we do this, TypingDNA has a JavaScript SDK, which we inject into the Azure AD B2C web pages. And that's how we collect the typing profile of the user. So as they enter their email and password, the TypingDNA SDK will calculate a specific profile for that user. Now that data is sent back into Azure Active Directory B2C, and B2C will communicate to the TypingDNA service to, for example, register the user's typing profile if it's a sign-up, or verify the user's typing profile if it's a sign-in. And the TypingDNA engine will give Azure AD B2C a score on how likely it believes that this is the user who has been using these credentials in the past. And B2C can then do something with this data, whether it's going to allow the user to seamlessly authenticate with no further challenges, whether it will present another challenge, like, for example, multi-factor authentication, or maybe even just block the user. So you have flexibility on what will actually happen when the typing characteristic has been analyzed. Okay. So I'm just going to dive straight into a demo so it makes a little bit more sense what this looks like. So to start the demo, I'm going to do a sign up. So this is your user who's trying to sign up at your website. I've got a basic form here, which is asking the user for a username and to confirm their password. Now on this page itself, this is where we're actually hosting or we've injected the TypingDNA JavaScript. So we'll have a look at what that looks like. So in the page here, we've got the TypingDNA JavaScript being embedded. Now I've actually embedded the entire JavaScript in raw format, but you do have the ability to just reference the source. This approach just improves performance. Now I'm going to try a sign up. Now behind the scenes here, the TypingDNA JavaScript is calculating my typing profile, and it will be sent to B2C. And I've registered an account. So at this point, the TypingDNA service has understood my typing profile, and it's assigned a unique user ID for this authentication. Essentially, it's a hash of my email and my B2C object ID that was created. And so this uniquely identifies me in the TypingDNA database so that I can have my credentials analyzed on subsequent authentications. So let's do a sign-in now. So again, on my sign-in page, I've got the TypingDNA JavaScript being loaded up here. If I remember the account, test 4. So again, my characteristic has been determined with the JavaScript on the front end, and then processed by the TypingDNA service through Azure AD B2C. And in this case, we have returned back a token to the application, which I'm parsing on this screen. And in the claims here, we can see that this was my email, my sign-in name, and the net score here is actually the score that TypingDNA has returned back to B2C. I do have the 2 other claims here, which are essentially flags to tell B2C what to do. Now, this specific integration has an API sitting between the Azure AD B2C service and the TypingDNA service. And it's actually managing the communications between B2C and the TypingDNA endpoints. So it understands the typing, the scores coming back from TypingDNA and has some logic in there to determine what should it return back to B2C during the authentication to tell it to do something. Now, as debug purposing, I've actually just output that data into the token. So my API returning back to B2C asked B2C to prompt the user for MFA. And in this case, also save the typing pattern because it thought that with the number of attempts that this user has tried to authenticate with, this score is good enough to profile the user again and add that to its characteristics. So these kind of flags, and when you would like to save patterns, you can adjust the thresholds in that API which communicates between B2C and TypingDNA. In my case, I'm actually prompting the user for MFA on the first couple of patterns that are being saved, so that I definitely know that the patterns at the start of the user's authentications are definitely being saved for the user that I know must be who they say they are, right? That's why I prompt them for MFA here. So let's do this again and see what happens. So I'm going to do a sign in again. And so my net score here has gone up to 78. So the system is trying, or TypingDNA's service is understanding that this user is more likely to be who they say they are. The typing pattern seems to be well, it's getting closer and closer each time I'm authenticating. And let's do this once more, see what happens. And so this time my net score is really high, it's 87, which is saying that the TypingDNA service is pretty happy. So this is really, you know, the person who set up this account is really the person who's attempting to enter these credentials. And now the interesting thing here is that the MFA prompt from B2C, or at least my API, has now judged that based off the number of patterns that we're aware of for this user and the confidence that the TypingDNA service has provided back that this credential entry was very similar to what it's seen in the past, it's now telling B2C, hey, you do not need to prompt this user for MFA at this point. And we also save that typing pattern because we know that at this point we have really high confidence that this is the user. Now I'm going to show you something interesting, more interesting. This time what I'm going to do is I'm going to put the credentials in again, but this time I'm going to copy and paste the password in that I've been using for this demo. So I'm just going to paste the password and click continue, which would simulate pretty much what a bot would be doing. if it was trying to very quickly try to harvest credentials, for example. So in this case, B2C is just throwing the user to prompt MFA, and that's because the TypingDNA service did say that, this is not something that we really have seen before. So that's how we've analyzed and reacted on the typing characteristic of the user itself. So I'm going to show you just a couple of other demos that I ran. I'm going to show you one where the user enters a so here, this last test I did, in this case, this is actually a colleague of mine who I had typed the password in for this account, which had done a number of authentications already. So they've actually got the password. So this wasn't a copy and paste attempt, but this was just, someone has got my password and they've just tried to access my account. And so again, the TypingDNA service has understood that, we do not really recognize this typing characteristic, and it's returned a lower score back to B2C, and we're now prompting for MFA. So I'm not showing you the prompt for MFA, but essentially B2C understands that in this case, we would be prompting the user for MFA. Okay, and the last thing I'm going to show is where you can find all of this. So in our Azure AD B2C repo, we'll send everyone a link if it's not in the slides. You'll find a repo called Partner Integrations, and you will find the TypingDNA sample in this repo. And the repo itself will give you a brief intro on what it does, how it works, and how this integration has been set up with Azure AD B2C. Any modifications you need to make and any samples for the APIs are also included inside this repo. And I do also state the training modes that I've configured inside the API, which brokers the communication between Azure AD B2C and the TypingDNA service itself. You may want to reconfigure these based off of your specific environment. If you are in the banking industry, you may always ask for MFA, or always challenge the user further if the user has only just started using the service until their confidence score has increased to a certain level. It's kind of down to you how you want to actually do the implementation in terms of bringing in any other factors on top. Of course, that's not necessary either. You may just be relying completely on TypingDNA confidence score as the second factor entirely. And I also have quick and dirty instructions on how to set this up. And I've also provided links to the live demo that I was just showing you guys. So if you want to try, you can sign up and you can sign in and you can play around with the demo to see what kind of scores you're getting back. You can give it to your friends and let them try and break into your accounts. And one more thing I'll show is the TypingDNA portal itself. So in the TypingDNA portal, you will see the logs for all of the accounts, whether we're verifying or checking the user's credentials, or sorry, not their credentials, but checking the user's typing pattern, or whether we're saving the user's typing pattern. So I can see, for example, for this user that I just signed up, I can see what's happening. I can see how many devices were recognized, how many patterns we've saved, technically how many passwords we've got, and a summary of all of the operations that were happening against this account in the TypingDNA service itself. It gives them some neat information around the scores that were given, the confidence, what device was being used, the IP address, and how long it took. So this is only a web demo, but this also can be implemented on the mobile device. On the mobile device is an extra layer. Not only is the typing pattern being analyzed, but also how the user is holding the device or how they're moving the device. So the JavaScript will look at the data points being brought from the gyroscopic data on the device itself to add that into the profiling of that user's typing characteristic. and then the same process occurs. It can store the typing pattern and verify the typing pattern on subsequent authentications. Okay, I think that's all I had. Hope that was interesting. And yeah, you want to take back, Madalena?
Sure, thank you, Jess, for this. We now know where we stand today, so let's see also what the future holds. Our next speaker, Tudor, is going to tell us about the future of authentication.
Great. Thanks, Mother, for the intro. Thanks a lot, Jess, for the comprehensive demo. So in our view at TypingDNA, the integration of TypingDNA into Azure AD B2C is a very important step towards silent two-factor authentication and risk-based authentication. Now, as both Madalena and Nasos have pointed, for a long time, user experience and security have been at odds, right? And with this, digital product managers who are looking for better user experience have been at odds with CISOs and the people usually managing authentication and the security of applications. And this is understandable. From a user experience perspective, the customers are ever more demanding. A lot of services become commoditized, as Madalena mentioned, for example, current accounts and credit cards and so on. And also, due to the fact that the world is moving towards a pay-as-you-go model with very, very easy and quick enrollment, there's low switching cost. So product managers want less friction, better user experience. Now, from a security perspective, we have more than 3 billion credentials leaked in 2019. Probably it's going to be even more for 2020. And the volume as well as complexity of attacks are rising. And we see this especially accelerated by the current pandemic. On top of that, as Madalena mentioned, password hygiene is not necessarily at its optimum. People reuse passwords, they use weak passwords. So it's only natural that the people taking care of the security of applications want stronger authentication, but this often leads to worse user experience. And risk-based authentication is the way of solving for both and leaving everybody happy. In other words, risk-based authentication means friction, but only where it's necessary. And it's very, very close to what you've seen earlier in the demo. I'm happy to take you through the conceptual model of how this actually works. Now, when we think about a user session, we think about activities on a timeline, right? So the user logs in, they view some data, maybe change some settings, add some data, and maybe in some sessions they decide to delete all data or even change a password and then actually log out. Now, the thing is that not all activities actually carry the same risk. So here we added the risk dimension and we tried to plot this data on a risk scale. Of course, this is just for explanatory purposes. Now, of course, deleting all data or changing a password carries a much higher risk than just viewing some data, viewing some settings, and viewing some reports. Now, let's add the concept of trust or security, if you will. Now, traditionally, we want the security to be higher than the risk of the session. That is a place where we are comfortable, right? And most commonly, we will add one factor of authentication, which is usually something like a password. And as we have established so far, passwords are not the answer. Now, why is that? Well, the problem is that they actually leave a huge attack surface. So then what is the answer? Well, the industry has for a long time pushed the answer as being MFA in its most traditional way, knowledge, possession, inheritance. We've been through these things, and indeed, what this does is it shrinks the attack surface, right? So we can actually massively increase security and trust. The problem with this is that all users and all sessions are treated the same. So all users jump through extra hoops. And what we've seen from real data is that most activities of users are actually of low risk. So most users just log in to check their account balance or check the status of their flower delivery or anything like that. So the system is highly inefficient. And that is where a lot of the applications are today. Now, let's focus for a second on the risk-based authentication component, or the silent two-factor authentication component. Now, truth is that today there's a lot of context that we rarely harness. And why would we harness context? Where it's two very important points. First of all, context is fully invisible to the user. And that means that the user experience is not degraded in any way. The second great thing about context is that it's less transparent to attackers how the risk engine actually works. And here are some very good examples of context. So we can look at IP, as Nasos mentioned, with one of the plugins for Azure AD B2C. We can compute geolocation, geovelocity. We can look at device fingerprinting, and we can add things like typing biometrics, what TypingDNA actually offers. Now, when we actually add the initial authentication factor on top of the context, we have a trust or security level that should allow most activities for users. And from the user's perspective, the experience is exactly the same, but in reality, the system is a lot more robust. And what we will do is we will only trigger MFA when the risk exceeds the trust, like in this case, deleting data, changing passwords, and so on. So what that means is that most sessions do not incur extra friction. Just like you've seen, most sessions will just have the typing pattern confirmed, and they will just be able to get in. And where we are at risk and we decide to step up, we actually end up with more security than by just employing the traditional 2FA. And as I said, that's exactly what Jess took you through earlier, right? So we had one factor of authentication plus the context of typing biometrics, together dynamically triggering the need for a multi-factor authentication. Now, in terms of actionable items, like how do we actually get there? Well, I think the first point is getting a flexible identity and access management or customer identity and access management solution, just like Azure AD B2C, allowing for a lot of context and a lot of policies and flexible policies to be put in place. The second thing that you would want to do is map out and classify user actions based on risk. We probably don't want to go to the granularity of each action carrying a different risk level, so we can kind of put them in buckets. But still, this is a classification effort. Next, you will want to capture and understand this user context. And last, you would build the RBA rules or the policies, in this case in Azure AD B2C, that make sense for your business. And I think Jess actually covered a great point there by saying that those numbers can actually be configured. If you're running online banking, then you would want like a higher threshold, right? If you're running a different kind of business, you would maybe look at a lower threshold. So in a nutshell, that is our perspective on the future of authentication. And we're very happy to be working with Microsoft on bringing this future of authentication to life. Thanks a lot for listening, and I'm just gonna pass it back to Mada.
Thank you, Tudor, and thank you to all the previous speakers. We now hope that you are more informed about the advantages of typing biometrics and how easy it is to integrate them in your own Azure AD B2C project. We have some time for questions now, and we encourage you to keep asking us. So to go to the first one, can you tell us if how the integration is going to go from a pricing perspective? Do people need to get a separate TypingDNA account, and how would the invoicing go? Nasa, can you take this one?
Yes, of course. Thank you for this question. At this point, Azure Active Directory B2C and TypingDNA will have two different billing models, and two different invoices will be sent to you. So Azure Active Directory B2C has, the billing based on monthly active users, and additional, if you use multi-factor authentication from Azure, you will get an invoice, and then you need to have a separate contract and a separate billing agreement with TypingDNA. That's how it works today.
Okay, thank you. Second one, where are the typing profiles of the user stored? Is it on the TypingDNA's service? I can take this one, and the answer is yes. As you saw previously, just showed you the TypingDNA user dashboard, and there is also on the same interface where the typing patterns are stored. Nothing is in Microsoft. Second one, is it the typing patterns are updated every time when the user signs in, or is just registered when the user signs up? Jazz, can you take this one?
Yeah, sure. So yeah, I did say it's up. It's kind of flexible on your scenario, but let me give you at least a straightforward answer first. So obviously at sign up, you will be storing. The actual logic is that you check if the user exists first. If the user doesn't exist in the TypingDNA service, then you store the currently captured typing profile into the TypingDNA service, and they will store that. And then on subsequent authentications, then you need some logic as to when you would like to reprofile and also store the user's typing pattern. So in my demo, what I was doing was on the first couple of authentications, or at least on the first couple of attempts where we know that the TypingDNA service only has very few patterns stored. So for example, less than 2 or less than 3. What I do is I always prompt the user for a multi-factor authentication. And in those couple of cases, I then store the typing pattern. That gives a fairly organic approach to a couple of authentications that you can trust are definitely it really is the user, and therefore you can store the typing patterns in TypingDNA's service with good confidence, even though the confidence score from TypingDNA may not be as high. Now, as the user continues to save typing patterns, at some point the TypingDNA service will be quite familiar with the user's typing pattern, and then the net score or this confidence score coming back from TypingDNA would be much higher. And so you can use a scale there on how many patterns have been saved versus how good the score is as to whether you want to store another pattern. Okay, so there's a relationship between number of patterns stored and whether you want to store the pattern and the confidence score coming back. How you design that level up is a little bit dependent on your service itself and how much security you want to withhold. So you could say, if the user's done MFA, I'm just going to store it. Or you could say if the user's not done MFA, but I have 6 patterns already and the score was 99, I'm definitely going to store that, right? So it's kind of down to you a little bit on how you want to create that logic.
Okay, thank you, Jess. Hope things are clearer now. And Tudor, now we have one for you. What happens if I suffer an injury that will affect my typing?
Yeah, thanks. That is a great question, and it's a great question worth answering in the general context of biometrics. Now, biometrics, as per their definition, they will measure the individual, either in their physical or behavioral traits. And all biometrics are subject to changes in environment or changes in the individual itself. For example, if you're trying to run facial recognition on your typical smartphone and the light shines from the back, you're going to have an issue. Or you're trying to do fingerprint while your finger is wet, you're trying to type with a broken finger, or you're trying to, I don't know, walk while drunk. So in all these scenarios, the biometric factor will actually not be able to recognize the individual. And what is very important is that most biometric factors should actually be used in conjunction with fail-safes. So in this scenario, for example, you saw that there's a prompt for MFA, and ideally these authentication factors that you're basically stacking on top of each other should be independent, so that the inability of using one should not result in the inability of using the next one.
Thanks, Tudor. And just one more to you. How do you deal with the users who have password managers?
Yeah, so this is a very good question. There's a couple of approaches, and Tudor, you might want to you might want to fill in here as well. So the first thing is you have password managers and you also have autocomplete. So the ideal scenario is, at least from a browser perspective, you can remove the autocomplete from the HTML so that the user can't just have the browser insert the password, because that will give them bad experience after the initial sign up. The sign-ins wouldn't be able to generate a proper typing characteristic to send back to TypingDNA. So there's one thing you can do just to make the UX better. Now on password managers, actually, I'm going to ask Tudor as well here, but I would think that, yeah, go on.
Yeah, sure. So this is again a matter of balancing user experience and security. So if we go back to what I said about context and understanding user context, generally sessions that come with autofilled credentials are of two types. Either they're highly risky ones, because someone actually injected the credentials, like an attacker has injected the credentials, or they are highly secure ones because someone uses a password manager with a highly complex password. So it's hard to actually tell which one it is. So generally, it's a good idea of treating the automatically filled sessions as being a higher risk kind of session, and actually pushing MFA. Now, from a user experience perspective, there's things you can do. One example is what you mentioned, Jazz, preventing autofill. This, of course, has an impact on user experience. Another option is to, for example, only prevent autofill on the username and not on the password. And last but not least, you could have the user type something slightly different, like a set of 2 to 3 words in a different field if you want, next to the username and password. So TypingDNA is not necessarily linked to the username and password which the user is typing. We can look at virtually anything the user is typing anywhere and at any point in time the user is typing. So
yeah, that's really good. Yeah, it's a really good point. So yeah, I'm just going to echo that in the demo, I'm profiling the email and the password fields. But as Tudor said, the second factor can even be another typing profile analysis where you ask the user to type just a phrase to see how they type the phrase. It's not consistent on just the actual string. That's not a requirement.
Okay.
But yeah, I guess in summary, you would have another factor basically, and the UX of that factor, there's various ways to make that better. In the case of password managers and autofill.
All right, we have one more question on what is the source of the compute power to analyze the patterns, and the answer to that is the TypingDNA servers. So your Azure AD just receives the net score and the other API responses from TypingDNA. Tudor, we have one more directed to you, which is to your slide on risk analysis. Where would passwordless fit in?
So yeah, thanks a lot for the question. I think passwordless is a very important concept that is part of the future, definitely. As I mentioned earlier, TypingDNA is not in any way specifically linked to the password itself. What we need to keep in mind when we're discussing about passwordless, passwordless does not necessarily mean completely dropping a knowledge-based factor. If you move towards something like a possession-based factor, like an SMS one-time password, email one-time password, software token, hardware token, and so on, and want to add, for example, the biometrics as a second factor of authentication, that is perfectly fine, and in a lot of cases, it will make a lot of sense. However, if one of those actually fails, as I mentioned earlier, you do need a failsafe, and this failsafe should be independent. And in most cases, we will still end up relying on knowledge-based factors, which don't have to be passwords in itself, but knowledge-based factors. I honestly don't think they're fully going away very soon.
Okay. Thanks for that. And to do one more for you, is the pricing model for TypingDNA based on the number of accounts or the number of API calls?
Sure. So the standard pricing model for TypingDNA is a user-based model.
Okay, thank you for that. And we hope that we managed to answer all of your questions. If not, we will follow up afterwards. And I want to thank you all for attending, as well to our speakers for giving these presentations. We're going to send you the slides and the recording as a follow-up in the next days, together with a short survey to help us improve. And for anything, don't hesitate to contact us. We're more than happy to answer questions and give you more information. Thank you and have a nice day.